Okay, this is the P2 paper from January 2024. It's question number 6, and as we can see, this starts off with some exponentials and logarithms. We're going to be solving an equation using logs, and then when we get down to this part down here, that's going to be algebraic methods. We're going to be using factor theorem, algebraic long division to try and finish off the question. Let's have a look at part A though. So part A says, given all this information here, can we try and change it into this cubic equation? Yeah, absolutely we can. Let's get started and write out what we've got first of all. So we've got 2 log base 4 x plus 3 plus log to the base 4 x is equal to log to the base 4 4x plus 2 plus a half. So what I'm going to do is get all the log to the base 4s on one side, and then we'll start using log rules to see if we can simplify everything. So I'm going to use a log rule straight away with this term here. If we've got 2 log 4 to the x plus 3, using one of my log rules, I can take that power up there. So I'm going to do that with the first term. So we've got log 4 x plus 3 squared. I'm not going to do anything with that second term, log 4x, and then all I'm going to do with this term is take it over to that side, so I'm going to get minus log 4x plus 2, all equals to a half, and then here I've got log a plus log b, and then minus log c. Well, log a plus b will be log AB, and then if you minus c, that can be divided by c, so I'm going to do all that to the terms that I've got there, which is going to give me log to the base 4 x multiplied by x plus 3 squared. Well, I'm going to put the x first. x plus 3 squared, that's combining those two, and then because of the 4x plus 2, all divided by 4x plus 2, so that is now equal to a half, and I wanted it in this format. I wanted it in the format of just log of one thing is equal to something else. So now we're going to use this idea that if I've got this situation, I can change that log statement into a power statement. The way that we do it is we remember the base of the power statement is going to be the same as the base of the logarithm. And we know that a logarithm is a power. So that part must be there. So we get a to the c equals b. Well, I'm just going to do that with this thing here. Okay, so let's just get rid of all of that and then follow exactly the same idea. So the base of my power statement is the same as the base of my logarithm. A logarithm is a power. So that part there works out to be equal to everything that's inside the bracket. So x plus 3 squared all over 4x plus 2. Well, 4 to the half square root of 4 is 2. So I'm going to get 2 equals x plus 3 squared over 4x plus 2. And just remember what we're trying to get this to. It was that cubic, wasn't it? So it shouldn't take too many more steps now. Multiply everything by 4x plus 2. So I'm going to get ax plus 4 equals x. Well, I may as well multiply out this x plus 3 squared. I know I'm going to have to in a minute. So x plus 3 all squared. You take your time to do it if you need to. I can do that quite quickly. But if you need to do x plus 3 times x plus 3, just do it nice and slowly. So then we've got ax plus 4 equals, what's that, x cubed, 6x squared, and 9x. And now if we take everything all over to one side here, we're going to be left with x cubed, we've got 6x squared, the 9x and the 8x combine to make x there. I'm going to take the 4 over to the other side as well. So we end up with that equation there, which is what we were trying to get for part A. So fantastic, A done. B then says, given that minus 1 is a root of that equation, can we use algebra to find the other two roots? Yeah, so we're gonna factorize and find the other ones. So we're using the idea, part B, if x equals minus 1 is a factor, sorry, is a root, then x minus that, so x minus minus 1, x plus 1 is a factor. If x plus 1 is a factor, what I can then do, this is B part 1, is do algebraic long division now to see if I can work out what the quotient's going to be, what the quadratic is going to be. So if I take my x cubed plus 6x squared plus x minus 4, if I divide it by x plus 1, that'll tell me what the quadratic part's going to be here. So quick reminder how we do this. How many times does x go into x cubed? It goes in x squared times, so I'll put x squared up there. I then multiply x squared by all of this term, and I write the answer here. X squared times x is x cubed, x squared times 1 is x squared, and at this stage then, I subtract all of that out. So x cubed minus that one, 6x squared minus that one, that's going to give me 5x squared, and then all I do is I bring down anything that's left there, in this case plus x minus 4, and then I simply repeat that process a couple of more times now. How many times does x go into 5x squared? Well, I'm going to do it much quicker than that now. So how many times does x go into 5x squared? It goes in 5x times. 5x multiplied by x plus 1 gives me 5x squared plus 5x. We then subtracted, didn't we? So let's subtract there. Be careful. X minus 5x is minus 4x. Bring those values down, which is only the minus 4 this time. Last time of doing it. Now how many times does x go into minus 4x? Well, it goes in minus 4 times. Minus 4 times by my x plus 1. And brilliant, I wanted to have a situation here where there was no remainder when I subtracted them. So I've now been able to say that x cubed plus 6x squared plus x minus 4 factorizes to x plus 1 x squared plus 5x minus 4, and we want to solve both of those two equals 0. So I've got the quadratic that I need to be able to solve. It doesn't factorize, so taking the quadratic, I've got x plus 1 equals 0 will give me x equals minus 1, and then x squared plus 5x minus 4 equals 0. As I say, we need to use the quadratic formula on that. So x works out to be minus b plus or minus the square. You know the formula, so that's going to be minus 5 plus or minus the square root of 5 squared minus 4 lots of a lots of c, which is 4 times 1 times minus 4, all over 2a, all over 2. Well, I'll leave you guys to do that and work it all out. It works out to be minus 5 plus or minus root 41 over 2. So what were we trying to do? We were trying to solve the other two roots of the equation. So the other two roots of the equation are here. Minus 5 minus root 41 over 2 and minus 5 plus root 45 plus root 41 over 2. Part 2 says because we've done that, can we actually solve this equation? Well, solving this equation is solving this equation. So let's just write, in fact, I'll just use that bit up there. If I'm trying to solve that equation, I'm just going to use the iPad to put it in the right place. To solve that is the same as x cubed plus 6x squared plus x minus 4 equals 0, which gives me x equals minus 1, x equals minus 5 minus root 41 over 2, and then x equals minus 5 plus root 41 over 2. And you might think, what's the examiner doing? Well, it's the same answer again, but now we're distinguishing between the fact that if we're solving the log equation, I don't want the log of a negative, so that's the only solution then that would solve the log equation there. So just make that nice and clear. Discount the other two, so no know, just to make it clear to the examiner what I'm doing for that last part. So yeah, that's question number 6 all finished. Hopefully that all makes sense to everybody.